Today we are going to learn the 4.5 notes solving absolute value inequalities. First we are going to do the review problem, which is solving an absolute value equation. In order to solve an equation with an absolute value, we first need to get the absolute value part by itself. That's the part that is highlighted in yellow. The first step we're going to do is subtract 9 from both sides. And when we subtract 9 from both sides, we end up with 4 times the absolute value of negative 2x plus 8 equals 8. That 4 on the outside on the left doesn't need to be there. It is multiplied times our absolute value. So we're going to divide both sides by 4, and we get 2. When we split this into the two equations, the first one is going to match our equation perfectly, except we're going to get rid of the absolute value bars. So we've got negative 2x plus 8 equals 2. Then we use the word or because x cannot be both of these numbers at the same time. And our second equation is negative 2x plus 8 equals negative 2. The only thing that's really different about these is the first one has the positive version and the second equation has the negative version of the two. Both of these equations can be solved the same way, so we're going to subtract 8 from both sides of both equations. We end up with negative 2x equals negative 6 and negative 2x equals negative 10. At this point, the negative 6 and the negative 10 should be different numbers. They should not be opposites of the same value. So this is really encouraging. We're going to go ahead and divide by the negative 2 that is multiplied times the x by both sides of both equations. And we end up with x equals 3. We bring down the word or, and then the other equation gets us x equals 5. So those two values, if you plug them in for x into our original equation, would make that absolute value equation true. Today we are setting up absolute value inequalities. Our 6 steps to solve absolute value inequalities are 1. Solve to get the absolute value alone on the left. We already did that in this last problem, so it's very similar. This part is new. Number 2, determine the problem type. So a less than or less than or equal to will be an and shade between. Greater than and greater than or equal to problems are or problems, and you shade outside, so towards positive infinity and towards negative infinity. Then step 3, split into 2 inequalities, normal and reverse reverse. That's very similar to in our absolute value equations. We split into the 2 equations. Then we solve them separately and graph. We'll do step 6 later on in the next section. Okay, example 1, we have absolute value of 5x plus 10 is greater than 55. Since this problem is already solved with the absolute value on the left, we can go ahead and go into step 2, which is to determine what type of problem this is. It's a greater than sign, so it's a greater than or shade out problem. Step 3 is going to be to go ahead and write out our first inequality. So our first one is going to be 5x plus 10 is greater than 55. We really just copy down what we had to begin with and we get rid of the bars. Since we have the word or, we're going to write the word or between our 2 inequalities. Then our second inequality is going to be basically the same as the one we just wrote, but after the 5x plus 10, we are going to flip the inequality sign, doing a reverse, so it'll be a less than instead of a greater than. And then we reverse the 55 also, so it becomes negative 55. So that's the setup for this inequality. Let's take a look at example 2. In this problem, the absolute value is not alone on the left. It is divided by a 5. So in order to get rid of that 5, we're going to multiply both sides of this inequality times 5. And the 5 that we multiply on the left is going to cancel out the 5 that's on the bottom. So we're left with the absolute value of negative 7 plus 3x is greater than 20, which was 4 times 5. At this point, the absolute value is by itself, so we get to figure out step 2, which is what type of problem is it? We have a greater than sign, so again it's going to be an or problem, and or problems you shade towards the outside. Let's go ahead and split this into our 2 different inequalities. We're going to end up with negative 7 plus 3x, which is just the part that was inside, is greater than 20. And then our word or from up above, because it's a greater than problem. And then we keep our inside, negative 7 plus 3x. And we reverse reverse, making it a less than negative 20. For example 3, again, we need to get the absolute value by itself. which means we have a 4 that we need to add to both sides. We get negative 5 times the absolute value of 4x plus 3 is greater than negative 95. Now that negative 5 on the left is multiplied times the absolute value, so in order to get rid of the negative 5, we are going to divide both sides by negative 5. So we're left with the absolute value of 4x plus 3 is, and it looks like I screwed up that, it is going to be less than 19 because we're supposed to flip that sign. Make sure you change the direction. That is so important because if we looked at step 2 first, we would have seen that the original problem had a greater than sign, but once we have the absolute value alone, it is a less than sign. So make sure you get the absolute value alone before you decide whether it's a less than or a greater than problem. Step 1 first and then step 2. Really does matter. Okay, so less than and between for this problem. We're going to do step 3 now and split this into 2 equations or 2 inequalities. It says 4x plus 3 is less than 19, and because we have the word and now, 4x plus 3, and we reverse, so we have a greater than sign and a negative 19. Example 4 is a continuation of example 1, so we are starting off on step 4 in this problem. So I'm just copying down the inequalities that we got after step 3 in example 1. We're going to subtract 10 from both sides of both inequalities. This should look really familiar to when we solved absolute value equations, like in our practice example, the very first one. We end up with 5x is greater than 45, and 5x is less than negative 65 when we subtract 10 from both inequalities. Next up, we divide all 4 parts by 5, and we end up with x is greater than 9, or x is less than negative 13. Let's graph this now. We've got negative 13, 0, and 9 on our graph. From 9, we're going to have an open circle, and it says x is greater than 9, so we're shading towards the right. And x is less than negative 13, so open circle again and shading left. The word or means we should be shading towards the outside, and we did shade towards the outside, so that means that we got all of our signs correct. Next, we have example 5, which is a continuation of example 2. We are going to solve by adding 7 to both sides of both inequalities. So we get 3x is greater than or equal to 27. 3x is less than or equal to negative 13. We divide both sides of both inequalities by that 3. Since the 3 is a positive, we are not going to be changing our inequality signs when we bring them down. So we still have x is greater than or equal to 9, or x is less than or equal to negative 4.3 repeating. Let's label our graph with the negative 4.3 repeating, 0, and 9. Both of these points are going to get closed circles because of the equals bars on each one. We also know we should be shading out on both of them, but we should double check. So x is greater than or equal to 9, so closed circle, shade right. X is less than or equal to negative 4.3, closed circle, shade left. We are shading outside, which is what we were supposed to do for this OR problem. Now example 6 is a continuation of example 3, so I've copied those inequalities. Subtract 3 from both sides of both inequalities. 4x is less than 16, and 4x is greater than negative 22. Divide both sides of both inequalities by 4, and we end up with x is less than 4, and x is greater than negative 5.5. Okay, on our graph we've got negative 5.5, 0, and 4. Both of those values for a negative 5.5 get open circles because there's no equals under the greater than and less than sign. 4 shades to the left, 5.5 shades to the right. It looks like they are shaded towards each other. Remember that and is talking about overlap, and the two graphs would overlap just there in the center, so we can go ahead and just draw that barbell piece. Example 7, we need to get the absolute value by itself. Add 3 to both sides. Bring down your absolute value. We're going to be doing all of the steps on each of these problems. At this point, this is step 2. It is a greater than problem. Greater than or equal to, of course. Greater is or and out. Split this into 2 inequalities. Copy down the first one without the bars. Then the second one, we reverse, so we get negative, and we get a less than instead. And subtract 7 from all of the sides. getting 7x is greater than or equal to 56, 7x is less than or equal to negative 70, and divide all 4 parts by 7, getting x is greater than or equal to 8, or x is less than or equal to negative 10. Okay, we're making the graph. We've got negative 10 and 8 on the graph. Both of them are getting closed circles. 8 shades to the right, negative 10 shades to the left, and it was an OR problem, so we should be shading out. So that has confirmed that we did shade in the correct direction. Example 8. Absolute value is not by itself. It's multiplied times a negative 4. Do not get tricked into thinking that you should be adding 4 on both sides here. We are dividing by negative 4 because negative 4 is multiplied. We've got absolute value of 7x plus 3 is less than positive 11. It is a less than sign because we divided by a negative 4. Dividing by a negative number switches your inequality. So less problems are and between. We copy down the problem exactly without the bars. Second time we write it, we reverse, so the less than sign becomes a greater than sign, and 11 becomes negative 11. Subtract 3 from all 4 parts. 7x is less than 8, and 7x is greater than negative 14. Remember, the 8 and the negative 14 should look like different numbers. They should not be opposites of each other at this point. Divide all 4 parts by 7. 8 divided by 7 does not give us a whole number. We end up with about 1.1, and negative 14 divided by 7 is negative 2. So we get x is less than 1.1 and x is greater than negative 2. All right, let's graph. We'll put negative 2, 0, and 1.1 on our graph. Both the negative 2 and the 1.1 are going to get open circles. We're going less than 1.1, which means we're shading towards the left of 1.1, and to the right of negative 2. It's an and problem, so we should be shading between. We are shading between, so we have graphed correctly. And that also means that the signs that we got originally are correct. Example 9. We have to do 2 things to get the absolute value by itself. We're going to start by subtracting 5 from both sides. We get negative 9 times the absolute value of negative 9x plus 9 plus 5 is less than negative 76. Subtract 5 from both sides. And then divide by 9 and we get absolute value of negative 9x plus 9. We flip our sign is greater than 9. We get to split this into 2 inequalities. It's a greater than problem. So it's going to be an OR, and we're going to be shading out. Okay. First inequality we copy down perfectly, getting rid of the bars. Second one, we copy the inside, then we reverse, so it's a less than sign and a negative 9. Subtract 9 from all 4 parts. And we get negative 9x is greater than 0, or negative 9x is less than negative 18. Time to divide. We divide by negative 9 on all 4 parts. And we get x is less than 0, or x is greater than 2 because we are going to be flipping. So we divided by a negative number. Okay, let's graph. 0 and 2 both get open circles. Less than 0 means we shade left, and greater than 2 means we shade right. This is an OR problem from a greater than, so that means we should be shading out. On this last problem, we don't actually have to show any work. That's because we have the absolute value of something, anything, is less than negative 8. And we know by the definition of absolute values that the absolute value of anything cannot equal a negative number. So let's think about this. The absolute value of x plus 3 is less than negative 8. That means that the only values of the left side, x plus 3, the absolute value of x plus 3, are positive. And then we have that positive numbers are less than negative numbers. We know that's impossible. Positives are always bigger than negatives. So that means that this example has no solution. There's no value for x that we could plug in to make this inequality true. All right, I hope you learned something. Have a great day.